Okay, guys, we're going to learn, review something you already know, and then we're going to learn a new triangle called the 30, 60, 90 special right triangle. And we're going to apply these rules and practice them. And then, for those students who haven't done it yet, I want you to download the worksheet from the drive, and we'll also post it on Backpack for you. Okay, so there's two types of triangles here. This is the one we've already done. This is called a 45, 45, 90 triangle, and it's, as we already know, if two angles are the same in a triangle, then we know that the opposite sides are the same. Okay? Of course, we know this is the hypotenuse, so we call this the hypotenuse, which I'm going to abbreviate as hype. And these are the legs. Now, both legs are the same length, so it really doesn't matter. But in the 60, 30, 90 triangle, which also has a special rule, we actually call this one the short leg. Okay, and we call this one the long leg. Remember, these are sides of a triangle, of course, and the hypotenuse, okay? And how do we know that? And this is just kind of a review, but the hypotenuse is always across. See, it's like an arrow here. See this arrow? See? It's across from the right angle. The right angle points to the hypotenuse. And then the short leg, which is this segment right here, is across from the 30-degree angle. There's the 30-degree angle. It's pointing across the short leg. Okay? Obviously, if this angle gets bigger here, then that blue side has to get longer. So you can see that this angle directly affects this blue side. And then here's the 60-degree angle, and that points to the long side, which is across here, and that's this leg. Okay, and you can see that that's longer than the short leg, both physically and, of course, you know it because of the angle. So this is called the long leg, this is the short leg, and this is the hypotenuse. So your first job in doing either of these two types of problems is to identify what was given to you. Okay, identify what was given to you. You have to know if you were told the short leg, the long leg, or the hypotenuse in the 30, 60, 90 triangle, or in the 45, 45, 90 triangle, were you given a leg or were you given the hypotenuse? And the formulas that we use is all based on a ratio, because all 45, 45, 90 triangles are similar to each other, which means they're proportional. And all 30, 60, 90 triangles, of course, are similar to each other, which means they're proportional. And the proportion is always the same between the sides within each triangle. For example, in this isosceles right triangle, the 45, 45, 90 triangle, if we call the leg x, and of course then the other leg is x, then this hypotenuse here will be x radical 2, or radical 2 times larger than x. Okay? And we often write it like this, 40 to help us, 45, 45, 90. Now, of course, that could be misinterpreted to think that those are angle ratios. They're not, right? Of course, they're not angle ratios. But the 45, 45, 90 just helps us realize those are the sides across from the 45 degree, and across from the 90 degree. So, leg, hypotenuse. Okay, let's go over to the 30, 60, 90. So the 30, 60, 90 triangle. And again, I'm talking about the sides across from these angles, has a ratio of x radical 3, and 2x. Okay, and now here it makes a difference, right? This is called the short leg. And you can tell it's the short leg because this long leg that I'm putting right here, this long leg is radical 3 times bigger, see? There's the plain old x here, and there's an x times radical 3. So obviously that's the long leg because the square root of 3 is about 1.7. So you're multiplying, roughly 1.71. So you're multiplying this x by roughly 1.71, or exactly by square root of 3. And that will give you the length of the long leg. And of course, the hypotenuse is double the short leg. Double the short leg. And that's really important. Okay, so the procedure is very simple. Of course, identify which of these triangles you have. Then ask yourself, which side do you have? And then all you do is set the side equal to one of these three things, right, in each of these cases here. So what I'm going to do is I'm going to copy this, and you can do the same, of course. And I'm going to keep this on each problem that we do. I'm going to try to copy it anyway. And so I can be able to copy it. All right. So let's go to our first problem. Okay. So first of all, you have to ask yourself which triangle do we have, of course, here. And in this case, obviously, it's 30, 60, 90, not a 45, 45, 90. So we write the rule down, which is x radical 3, 2x. Okay? And remember, this is the short leg, this is the long leg, and this is the hypotenuse, just to abbreviate a little bit, okay? All right. So what do? You ask yourself, which side do you have? Okay, which side do you have? So the only number that was given to us for the side length was 6, right? The 6 represents the length of this entire hypotenuse here, right? So the side length we were given to was the hypotenuse. How do I know that? It's across from the right angle. There it is. It's across from the right angle. That's the hypotenuse. Okay, so then what formula we're going to use is this. We're going to use this one. And all you do is set the two yellow things equal to each other. You set the two yellow things equal to each other. Now, if this had been, don't do this, but if this 6 had been over here, then I would set that equal to this. And if the 6 had been over here, which is the long leg, then I would have set the 6 equal to this. Okay, but we're not. That's not what happened. We were told, we were given the hypotenuse, so I'm going to set it equal to this. So you set the two yellow things equal to each other. All right, so what does that mean? Well, you just write it. You just write 6, that's the length of the hypotenuse, equals the formula for the hypotenuse, equals 2x. Okay, so that's the first thing, first step. Set given side equal to the formula. Okay, next step is solve for x. Now, in some cases, this is going to be a tough step. In some cases, it's going to be. So this one's easy, obviously. And I'm going to use symmetric property of equality to move to the side. I think everybody can see that x is equal to 3 here. No big deal. But this may take a little more algebra and certain other problems. Okay? And then the third step is simply find the other sides. Find the other two sides. Okay, well, if x equals 3, right, we just take this 3. Let me use a highlighter. We just take this 3 and we plug it in right here. And we plug it in right there, right? We just plug it in. So we take this 3 and we plug it in here. And that's 3. And we also take that 3 and we plug it in here. That's 3. Okay? So what is the short leg? Remember what the short leg is. The short leg is the side across from the 30-degree angle. So the short it's So there's the 30, there's the short leg, right? Okay, so what's the length of the short leg? It's just equal to x. Well, x is 3, so it's equal to 3. See, it's pretty easy. The hypotenuse is always double this leg, and this leg is always half the hypotenuse. Okay, and then down here, we're going to plug a 3 in here. Now, if you plug a 3 in for x here, if you just put a 3 there, it's easy. It's 3 radical 3. Now, normally you'd have to multiply it by radical 3, but in this case, it's already done for us. So it's just 3 radical 3. Okay, and that's it. You found the 3 missing sides of the triangle. To check your work, you always start with the short leg. The short leg is your friend here. See, the short leg is your friend. And you can go double to get to there, and you get times radical 3 to get to there. Okay, you always want to try to work your way to the short leg because the short leg is x. And from that, you can find anything. Okay. Let's go to the 45, 45, 90 rule. Now, I'd like you to pause the video, try this one on your own, because you already did this in class, so just a quick warm-up. You probably know how to do it pretty well. So pause the video, and then I'll solve the problem. Okay, if you got stuck, first of all, obviously this is an isosceles triangle, and it's a right triangle. So an isosceles right triangle is 45, 45, 90. These congruency marks told me it was isosceles, and it's got a right angle, of course, which forces it to be 45, 45, 90. Okay, the rule is x, x, x radical 2. This is leg, leg, hypotenuse. What is it that we have? We take a look. Say, oh, we have the hypotenuse. How do we know that? It's across from the right angle. See it? Across from the right angle. Okay. So we take this formula right here and we set it equal to this. 6 equals x radical 2. All right, now this is a little tougher, right? I said this might get tough, and it does here a little bit. So, and I'll use different color to help us. I need to get x by itself, see? So what is being done to x? Well, there's really a dot there, right? That means multiplied. So you're used to seeing something like this. See, if I wrote this, it's going to be very easy. If you see this, you're like, oh, you're going to divide by 2 on both sides because x is being multiplied by 2. Well, that's actually exactly what's happening here. It's just a notation that you're not as comfortable with as you'd like to be, some of you. But this means x times radical 2. So in order to get x by itself, we have to undo the multiplication and we have to divide. So we're going to divide both sides by radical 2. Okay, and of course this reduces. That's the whole purpose that we did it. And I'm left with x, right? So I'm just left with x, which is good. Now this is actually the right answer. This is actually the right answer, 6 over radical 2. It's just in the wrong form. It's like trying to pay pay a toll booth on the Parkway, on the Garden State Parkway, with 100 pennies. It is the right amount of money, but it's in the wrong form. So if you write this, you're going to get most credit, which is better than not getting anything. But what we have to do is what we call rationalize this, right? We have to multiply it by 1, because otherwise we're going to change the value. But this is a special form of 1, right? This is equal, its value is 1. That's why we're not changing anything. Value equals 1. Okay, so I'm just multiplying by 1, which is totally legal. But in this form, radical 2 over radical 2 is going to make this problem nicer. It's going to rationalize it. So it's going to be 6 radical 2 over the square root of 4. And of course, the square root of 4 is 2. So it's 6 radical 2 over 2. And then don't forget to reduce your fraction, of course. So you get 3 radical 2. Okay, so that's just, it's the exact same thing as what's up here. It's just a nicer form. And depending on the problem, we're probably going to want to fill the diagram in. How do I know I'm correct? Well, to go from the leg to the hypotenuse, I should multiply by radical 2. So to check your work, if you multiply this and the other one, and this one too, by radical 2, you will get to 6. And that's a good sign that you did the problem correctly. Okay, this is the hardest of all of them. This is the 30, 60, 90 rule, though, of course. So different than the one we just did. And we know, it's short leg, long leg, and hypotenuse, okay? And the formula is x radical 3, and 2x. Okay, I say it's the hard one. It's not that terribly hard. So it's just slightly more difficult. Okay, whenever you're given the long leg, and it's an integer, it's going to have to do the same thing we just did in the 45, 90 triangle a few minutes ago. All right. Now, again, it's the long leg. How do I know? It's across from the 60. I take the 60-degree angle. I draw an arrow. That side from here to here, which is a length of 6 units, that green side is 6. That's across from the 60. That's the long leg. So I'm going to set 6 equal to this. Okay, now when you solve for x, it's actually very similar to what we just did. You divide both sides by radical 3. Okay, and then we're going to rationalize. I'll put that over here, 6 over radical 3. To rationalize it, we multiply it by the denominator over the denominator. See, that's equal to 1. That's why it's legal. And you get 6 radical 3 over radical 9, which is equal to 6 radical 3 over 3, which reduces to, let me just rewrite it here, which reduces to 2 radical 3. Okay? So x equals 2 radical 3. Okay, so what is x? X is the short leg, see? So I'm just going to label that as the short leg. So I'm going to put it right here. Sorry. 2 radical 3. Now, how do we get to the hypotenuse? That's the only missing side left. Well, the hypotenuse is whatever x is times 2. Whatever x is times 2. Okay? So whatever x is, which is right here, this is what x is, times 2. So 2 times 2 radical 3. Okay? Believe it or not, a lot of people have problems with this at every level that I teach. A lot of people have problems with this because when you see these parentheses, right, you go into an automatic, what I call pattern recognition. You're like, oh, that's a pattern. I've seen that. For example, I'm going to do something completely different over here on the left. When you see those parentheses like this and there's stuff inside it, you are thinking distributive property. You're like, oh my God, I got to go into both of these terms, right? For example, if I had something like x minus 2, you'd be like, oh, there's a 2 outside the parentheses. I have to distribute. So your instinct often is to distribute. And you look at this problem and you're not really sure what to do. But if you look at the difference, right? This is a binomial. It has a minus between these two terms. It's a binomial. This is a monomial. This is a monomial. Okay? And if you go back to pre-algebra or 5th grade math even, and you ask yourself, how would I multiply 2 times 3 times 6? Right? There's a lot of ways to do it. 2 times 3 is 6, times 6 is 36. See? So what you really did is you multiply these two together, okay, get the result of that, and then multiply it by 6. But you don't, right? You don't, I want to be very clear with this, you don't multiply the 2 by 3 and then the 2 by 6. You don't do that, right? You don't put 6 and 12. You don't do 6 times 12. That will not equal 36. Okay? So all this side work here, just to make sure you understand, just because there's a parentheses here does not mean you're distributing. Okay? This is a monomial. So it's just 2 times 2, which is 4, times radical 3. But radical 3 doesn't go well with 4, right? We can't mix these. So we just leave it like that. It's just two things multiplied together. And that is simply double this, right? That's double this. Okay, moving on. All right, give this problem a shot. Pause the video. Solve the problem into your iPads or on paper, and then start the video again. Okay, they only gave us one angle here, but obviously the other angle has to be 45. And obviously that makes this an isosceles triangle. And then, of course, if that's 6, then this is 6. So we're already halfway done with the problem. And the formula for the 45, 45, 90 triangle is, of course, x radical 2, where this is the leg, and this is the hypotenuse, right? Okay, well, which one do we have? Well, we have the number across from the 45. We have the leg. So what does that mean? That just simply means that x is equal to 6. We set this equal to this, okay? X is equal to 6. Okay, well, then what would this be equal to? Well, let's just plug a 6 in there. That's it. It's that easy. You're just plugging in a 6 for this x right here. So you're taking the 6, you're plugging it into this formula, and you go, oh, 6 radical 2. Done. Remember, the hypotenuse here, this hypotenuse, will, in a 45, 45, 90, in a 45, 45, 90, will always be radical 2 times bigger than these legs. Okay, give this one a shot. Pause the video, and then I'll solve it for you. Okay, the 30-60-90 rule is, oops, my bad. The 30-60-90 rule is x radical 3 and 2x. Okay. And of course that's the short leg, long leg, and hypotenuse. Okay, so which one do we have? Which one do we have? We have this one, which is across which is across from the 30. Okay? It's across from the 30. So we have the short leg. And that's what we're interested in. Here's the short leg. Piece of cake, right? So x equals 4 radical 3. Whoops, I still have the highlighter selected. So x equals 4 radical 3. Well, that makes the problem pretty easy, right? Because now to find this, what do? I plug this 4 radical 3 into x. Now be careful. A lot of people think the answer is 4 radical 3. Let's be really careful, right? You know, we've taught you this many times. When we substitute for a variable, we replace it with a parentheses. When we plug a number in, we're supposed to replace it with a parentheses. So I'm going to take this x radical 3, see, I'm taking this thing right here. is circled x radical 3, and I'm rewriting it like this, right? So this is what x is, see? This is what x is in here. Okay, and what is x? Well, x actually is a numerical value we solved for. 4 radical 3. And, oops, I laid that. 4, oh, do I have magic pen selected or something? Okay, 4 radical 3. So when I multiply this together, it's 4 times 4 times 4 times, oh, I'm sorry, I messed up. It's 4 times radical 3 times radical 3, okay? All right, and that's 4 times radical 9, and that's equal to 4 times 3, and that's equal to 12, okay? So we just found the long leg, which is up here. Sorry, it's really, example should be moved over here. And we found that this is up, not 4, 3, 12. Okay, again, this is radical 3 times bigger than this side. The long leg, that's this leg here, the long leg is always radical 3 times the short leg. Okay, and then to get to the hypotenuse, we're going to take the same x right here, and we're going to plug it into here. Okay, so for the hypotenuse, which is 2 times x. Notice I'm using that parentheses again for my x, right? And what am I going to put in here? I'm going to put this 4 radical 3 in there, which is x. Plug it right in here. I get 4 radical 3. And again, just like we talked about earlier, 2 times 4 is 8. And the answer is 8 radical 3. Okay, hopefully you guys got that one right. Okay, now we can do some really powerful things with 30-60-90 rule and 45-45-90 rule. And believe it or not, you've probably heard the word trigonometry. This actually is trigonometry. We're just using, it's really an intro to trigonometry, and we're using 2 very easy pattern trigonometry ratios. And we call them special right triangles, and we teach it to you before we actually teach you trigonometry. But we're really solving this problem with trigonometry. Okay, so Albert is standing at point A. I'll just make a point A. And this is one of the hardest things you have to do is drawing your own diagram, so that we will have, once in a while, a problem like this where you have to draw your own diagram. Albert is standing at point A. He takes a sighting to the top of a cliff, point C. So I'm going to put a top of a cliff up here at point C. So he takes a sighting, okay? Sighting means he looks at it, right? So he looks at point C. And then this is new, so I didn't expect anybody to know this here, okay? We're going to learn this more about in the next unit. So this would probably not be on the quiz in this form, okay? Because this is something we're going to learn soon. But once I set the problem up, that would be a viable quiz problem. Okay, it says the angle of elevation. That just means how much you look up. See, normally you're looking straight across. See? Like this. You're normally looking straight across. I'm going to actually use a straight line tool for that. And I'm going to use a different color. Okay, so normally you're looking straight across at the horizon. Well, if you look up and you tilt your head back 30 degrees, that's called the angle of elevation. Okay? But again, you wouldn't have to worry about this on the quiz. Okay, and here's, of course, the cliff is obviously perpendicular. This is really important. You have to form a right angle, right? So this is the cliff perpendicular to the ground. Otherwise, we can't do anything. Okay, now Becky. Becky is, that's Albert, okay? Becky is standing at a point B and takes a sighting to the top of the cliff also. Now, I don't know if point B is here. Is point B here, or is point B here? I have no idea, so let's take a look. It says the angle of elevation for Becky is 45 degrees. So if Becky had to tilt her head higher than you did, she must be closer to the cliff, right? If you walk close to the Washington Monument or the Statue of Liberty or anything else, or you're in a boat in the Statue of Liberty, if you walk closer to a tall building, the closer you are, the more you have to look up. So that's a clue that actually this is not the case and that Becky is somewhere over here. Okay? So Becky looks up at a 45-degree angle. Let's use a different color for Becky. Okay, so Becky looks up at a 45-degree angle, and that means here, 45 degrees. Okay? If the cliff is 100 feet high, find the exact distance between Albert and Becky. Ugh, that doesn't look good, right? So here's my x. I'm not going to use x, actually, because I want to use x for my formulas, right? So I'm going to use y. They're asking me for this distance here. And at first glance, this seems impossible. There's no formula for this. It looks nothing like the other problems that we've done. How can anybody ever ask us to do this? So one of the things that we constantly teach you about is if you can't find the answer to the problem, for example, in this case, if you can't find a length of a segment, don't try. Instead, find everything else in the diagram you can. Find other stuff, because that other stuff may lead you to this, okay? So I'm going to pretend this wasn't even the question. I'm just going to ignore this. And I'm going to say to myself, I have a 30, 60, 90 triangle and a 45, 45, 90 triangle, and I know a new rule about these that makes my life real easy as far as finding sides. So let's do that. Let's find all of the sides of this 30, 60, 90 triangle. And then we'll find all of the sides of this 45, 45, 90 triangle. Okay? Doesn't matter what order you do it in. And once I do that, then I'll worry about the question that they're asking me. If I just look at the question they're asking me and I don't know how to do it, and I give up, I haven't learned anything, I haven't tried it, I haven't, I'm just stuck and I can't go on. So don't always look for the answer to the problem. Instead, find things that you can find, and you'll see often, as it will be in this case, that the answer will kind of just pop out. Okay. Another trick here, which I like to do, is to actually, because these diagrams are overlapping, I like to break them into two diagrams. So I'm going to make a mini version here of the 30, 60, 90. See? So here's the 30, 60, 90. So I'm just pulling it out of the diagram, right? And I know that this side here is 100. Okay, well, what's the rule say? This is the 30-degree angle. I must have what? I have the short leg. I have the short leg, okay? So if that's the short leg, this becomes, well, actually, I'm going to stop here. So armed with this, I'd like you to pause the video and try the problem. Go ahead. And I want you to solve for the missing sides of the yellow triangle, which I already started to do here for you. And I'd like you to find the missing sides of the blue triangle, the 45, 45, 90, and just do that. And then if you can figure out the answer, that's great. All right, so pause the video. Try to find the sides of these two right triangles. Go. Okay, so hopefully, and if you followed all my examples before, this shouldn't be too tough. You realize that this is the short leg, so this is equal to x. Excuse me. Then this is equal to 2x. And this is equal to x radical 3. Okay, so in our diagram, that's going to make a 200 here. I'm not going to label the arrow, but here I am. Here I've got to be really careful because there's overlap. Okay, so that is the full length of this yellow triangle. All right, now the blue triangle, right? The 45, 45, 90 triangle. It's a terrible 45, 49 triangle, but it'll serve its purpose. We know that this is 100 and this is 45. Okay? And this is 45. And that makes this 100 radical 2 because x is 100. And don't forget, both legs are 100, see? So that's also 100 down here. Now, how do we translate these numbers into this picture? Well, we don't really need this hypotenuse, so I'm going to leave it out. This 100 you already knew. And really the only important thing we gained here was that this was 100 from here to here. And if these arrows help you a little bit, that's great. So let's recap. I didn't solve the problem. I simply said, let me find all the missing sides of the triangles because I know how to do that. And then I'll worry about the final answer. And it turns out, right, if you want to know how far it is, let's take a different color here. From here to here, right? Let's try to do purple, I guess. From there to there. How far it's from there to there. It looks pretty obvious now. See? Even though I didn't know what I was doing when I started the problem. It's this big length all the way here minus this length to give me what's remaining. So actually in radical terms, it's the big one, 100 radical 3 minus 100. Now, please do not assume that these are like terms and that, don't write this, right? This does not equal radical 3, which so many people like to do. 100 radical 3 divided by 100 equals radical 3, but 100 radical 3 minus 100 does not equal radical 3. If you remember, I said radical 3 is approximately, and you can throw this in your calculator, 1.71, right? Then you can imagine that times 100 is approximately 171 minus 100, which would be equal to, or approximately equal to 71. See? So if you I mean, this is the right answer. We usually prefer radical answers, but sometimes in a word problem, the decimals might be better. Somebody may be trying to know how far it's going to take me to get there. So normally this is a good answer. This is a good form because it's exact. But really, this is probably a better answer, and I didn't put it in the calculator. You can do that. And we didn't say what to round it to, right? So if we said round to the nearest foot, I think this is going to be pretty accurate, although I'm not 100% sure because that's all I've memorized. So put in your calculator, type 100 times radical 3, hit enter, press minus 100, hit enter, and round to the nearest foot, and see if you get 71. You might get 71. It might be, I think it's 71. It might be 72, but I think it's 71. But that's the point, right? Is you get the answer there. So both of these are the correct answer. This is probably a word problem form is better. For word problems, this decimal form is better, right? But both of these are acceptable. Okay, so now check backpack for your various teachers. Whoever's watching the video, you may have different teachers. Check backpack for what your teacher wants you to do based on this work. Thanks, guys. Enjoy the rest of your snow day.